Good morning students. So myself Akshay Mahendrakar. So in our last class we were in discussion with what? Surface tension as well as surface energy. Correct no? So in this today's class we will be discussing about one of the very important thing, that is nothing but what? What do we know as angle of contact? Clear? So what do we know as angle of contact? So whenever the liquid is in what we can tell, imagine a glass surface, as in the last 2 or 3 classes we are taking the same example. So with that example very easily we will come to know what do we know as meniscus as well as what do we know as angle of contact. Clear? So on that glass surface, okay, if we put some water droplet means it will become some curvy nature, correct no? In the curved manner you are going to get that water drop, and as time passes what will happen is it just slowly spreads out. Clear? So earlier when it became what's that complete curved manner, that is nothing but what? That is called as meniscus. Clear? The name of that complete part we are going to treat it as what? Meniscus. Okay? And one more important thing, this complete nature in contact, that means whenever the liquid material it is in contact with some other material, okay, then we are going to discuss about what special characteristic, that is nothing but what? Surface tension. Clear? Let us suppose on a petal or on any what is that, green leaves, okay, in winter season you will be familiar with these kinds of example. So what will be happening in winter season means, at early morning if you see means, completely on that petals or any green leaves means, you will be going to see water droplet completely in circle shape. That means completely circular shape, water drop will be present on that. Okay, and whenever as the general case what we had considered on a glass plate, when water droplet is there means, okay. So these all situations will be interconnected to each other. One by one we will be discussing. Clear? So first of all let me take about this simple case where you are having a glass plate, and when we put a water drop it will be forming in this shape. This shape is nothing but what? This is known as meniscus. Okay, this is nothing but what? Meniscus. And listen, this is nothing but what? The best example what we had considered on a green leaf, okay, or on a petal, or a still basic example if I want to give means, on glass surface if you apply grease or oil, on that if you place some water droplet you are going to get in this manner. Clear? And whenever you are going to get these kinds of manner, okay, for this complete liquid surface, okay, where the liquid surface is in contact with this solid, there we are going to draw a tangent. Okay, that means we are drawing a tangent where the liquid surface is in contact with the solid. Are you following? Where the liquid surface is in contact with what? Solid. And whenever we are drawing a tangent, it is making two different angles with this solid surface. Okay, one is this angle and one more is this angle. Okay, this angle is known as angle of contact. That means the angle where we are measuring, when the tangent is drawn at the liquid surface at the point of contact, the angle between the tangent and the solid surface which is inside this liquid, okay, not this part, this is not angle of contact, remember. So whenever we are drawing a tangent at a point of contact, whenever we are drawing a tangent at a point of contact on the liquid surface. That means the liquid surface where it is in contact with the solid surface, there we are going to draw a tangent, and the angle formed between the tangent and the solid surface which is inside the liquid. That means this part is nothing but part what here we are having liquid. Here we won't have any liquid. Got it? So this angle of contact will indicate us what? Whether it is making, that means whether the liquid is making the solid surface completely, or it is wetting, or it is not wetting. This is wetting case, this is just non-wetting case. So in this case, if I want to draw tangent, means how I can draw, can you just imagine? So first one, this is nothing but liquid surface, it is contact with this solid surface. At this point, I can draw the tangent. This is nothing but what? Tangent. I will mention here, this is nothing but what? Tangent. Okay, here, this is nothing but what? Tangent. Now again this tangent is making two angles. That means here is one angle and here one more angle. Clear? Which value you have to choose? Yes? Are you getting what I am telling? Which value you are going to choose here? Which is the angle? For that what we are going to treat? What is the angle of contact? Clear? So just concentrate. Here we are having one angle, as well as here we are having one more angle. What is the definition for angle of contact? What I had told you. Angle of contact is an angle drawn by a tangent, okay, drawn by this tangent, and this tangent has been drawn at the point of contact of this liquid surface with the solid surface. That means both liquid surface as well as solid surface, where they are meeting each other, where that complete what we can tell, sharing is going on. Clear? So then the angle made by this tangent with this solid surface, but that angle should be what? Inside the liquid. Remember, that means here in this case what we are going to treat, here we are going to have the angle of contact. This value is nothing but what? Angle of contact. Here this will be angle of, this will be angle of contact. Here this value will be our angle of contact. Now just carefully observe, here angle of contact is, which angle it is? It is less than 90 degree. Okay, this is nothing but what? Acute angle. And what is going on here? This angle is above 90. This is nothing but what? Angle of contact is obtuse angle. Are you following? So in first case, angle of contact is acute angle. In the second case, angle of contact is obtuse angle. Now question arises, whenever we are having the acute angle case, that means whenever the angle of contact is acute, then the liquid will be wetting the surface. That means this liquid will wet this surface. Are you following? And in this case what is happening? Liquid is not wetting the surface. Best example we can give for the second case is nothing but mercury and glass combination. Clear? So if you use mercury, and along with that mercury, if you are going to place that mercury on glass plate or glass completely means, okay, plain glass, then what you are going to get? In this manner, that mercury bonding will be. That means cohesive force between the molecules of mercury is stronger than the adhesive force between mercury and glass molecules. So that's why you are going to get this kind of shape. Are you following? So here angle of contact is acute angle, here angle of contact is obtuse angle. So with the help of angle of contact, we can determine nature of contact also. That means whether it is wetting the surface or it is not wetting the surface. Clear? And one more thing, in this complete angle of contact concept, that is nothing but what? First of all, you will be measuring angle within the liquid, that means angle between tangent and the solid surface, but that solid surface you are going to consider where liquid is present. Remember, where the liquid is present, at that case you will be considering what? Angle of contact. And here also, in this case also, where liquid is present, that side you will be going to treat it as angle of contact. Clear? So we can determine the nature, that means how what we can tell, the molecules, water molecules are in connection with what? Solid molecules. Okay, and based on here cohesive force is stronger, here adhesive force is stronger. Clear? Shall I erase the board? Clear? So wherever you are having in this manner, okay, angle of contact, you will be drawing a tangent here, and this angle is nothing but what? Our angle of contact. And in the second case, like this, okay, this is nothing but what? Basically angle of contact. So whenever the liquid is not wetting the glass surface, okay, it will be having the convex shape. Okay, remember, this is nothing but what? Convex shape. This is nothing but what? Concave shape. Okay, and now we are going to discuss about liquid drops as well as liquid bubbles. Clear? Shall I erase this part? Got it now? What is concave? What is convex? When we are going to get concave, convex. Okay, when it is not wetting the glass surface, that is nothing but what? Convex meniscus. Okay, convex shape. Meniscus will be completely convex shape. Yeah, you should have to remember that. Next, we are going to calculate what is excess of pressure, okay, in case of liquid drop as well as liquid bubble. First we will be dealing with liquid drop, next we will be dealing with liquid bubble. Okay, so excess of pressure in liquid clear? So let us suppose we are going to consider a liquid drop. So first one we will go for drop, better it is. So afterwards we will go for bubble, because drops is very easy. Clear? Excess of pressure in liquid drop. Okay. So let us consider a liquid drop which is of radius r. Clear? And let pressure inside be Pi, pressure outside be P naught. Okay. So where I can write, okay, excess of pressure, okay, so here inside pressure, here outside pressure, this is Pi, this is P naught. So excess of pressure will be Pi minus P naught. Okay, inside pressure will be maximum 1, outside pressure will be lesser 1. So extra pressure is nothing but what? Excess of pressure, which is nothing but Pi minus P naught. So we know that pressure is nothing but what? Force by area. Correct, na? So force acting on this, force acting on liquid drop is equal to, so if I want to separate force means force is equal to pressure into area, but pressure is nothing but what? Excess of pressure Pi minus P naught, okay, into area. Area for this liquid drop, okay. So what is the area? 4 pi r square, okay. So this is nothing but what? F, basically this is nothing but what? F. F is equal to Pi minus P naught into 4 pi r square. Yeah. So due to this force, what we are having Pi minus P naught into 4 pi r square. This bubble, okay, the bubble what? This liquid drop what we are having, its radius will increase. That means basically that complete drop will become bigger in size. So due to this force, F is equal to Pi minus P naught into 4 pi r square. So this r value, initially what we were having, r value r, okay, it is going to increase for next value, which is nothing but what? Small value, if I consider here, means final value will be r plus dr. But to increase that, some work has to be done, correct now? If some work has to be done means then only it will just get displaced, okay. So basically what is work done formula? You all know that what we known as work done. Work done is nothing but what? W is equal to force into displacement. Here displacement is nothing but what? dr. Clear? So F value here I am having, first let us substitute. W is equal to, F is nothing but Pi minus P naught into dr. Okay. So this work has to be done on this liquid drop by the force Pi minus P naught into 4 pi r square. But if this work has to be done means there should exist some potential energy, correct now? Initially radius was r, now it is changing for r plus dr, means due to some extra energy only that will be going to happen, okay. So the potential energy which is stored in that liquid drop, that we are going to calculate, clear? So potential energy, okay, excess of potential energy delta U is equal to, this is nothing but, first of all the surface tension value what we are having, okay, and first of all the surface tension value what we are having, and what is the increase in surface area. That means initially it will be of r, finally it will be of r plus dr, okay. So delta U is equal to surface tension value, okay, surface tension, which is nothing but what? T, because liquid drop will be having only one free surface, remember, T into next thing what I had told, increase in surface area, okay. So increase in surface area, okay, let us write increase in surface area, clear? So from this expression let us calculate by step delta U is equal to T as it is, you can keep increase in surface area. Listen, now excess of surface, that means new surface area will be like this dotted line above this solid line what we are having, this one, okay, surface area. So this surface area minus this surface area will give me increase in surface area. So what I am going to write, 4 pi, we know that 4 pi r square is nothing but what? Surface area for a sphere, okay. So for this one what is the r value? R plus dr, that's why 4 pi into bracket r plus dr whole square, 4 pi r square minus 4 pi r square, that means initial value. So if we want to cross check, means what we are going to get? Delta u is equal to t as it is. Okay, here what is remaining? You can cross check this a plus b whole square. You can expand this 4 pi into bracket a square, that is nothing but r square, plus b square, that is nothing but dr square, plus 2r dr, okay, minus this value 4 pi r square. Okay. So now delta u is equal to t as it is. Here the t surface tension value what we are going to write here, t as it is. Now 4 pi you can multiply inside 4 pi r square plus 4 pi dr square plus 4 pi into 2r is nothing but 4 into 2 8 pi r dr minus 4 pi r square. So plus 4 pi r square minus 4 pi r square will cancel. So here you can concentrate this dr whole square. Okay, then one term here we are having dr square. Listen, dr is very small quantity. Here increase in that radius, that is nothing but very small quantity. So if small quantity, if you are squaring, that means again you are going to get too small quantity. Clear? So dr itself is small quantity. If you are squaring that small quantity for dr square, means again you are going to get very small quantity. So that's why as dr is small, dr square term can be neglected. Clear? So as dr is small, this complete term can be neglected. So what I can write next step? Can you tell me? Delta u is equal to t into bracket. This 2 went, only this is remaining 8 pi r dr, correct na? 8 pi r dr. Now check. This work has to be done. To do this work, this much of potential energy is there. That's why what we can write, Pi minus P naught. We are equating Pi minus P naught into dr is equal to T into bracket 8 pi r dr. So dr will cancel. What is remaining? Can you tell me? First of all, dr is getting cancelled. Okay. Pi minus P naught. So here we are having 8 pi. Wait here. Just check 4 pi into 2r dr. Correct na? What we are having? T into bracket 8 pi r. So here dr here I had written Pi minus P naught into dr, but here f value, while substituting here I had forgotten this 4 pi r square, that is, it is nothing but what? Pi minus P naught 4 pi r square next to this dr. Yeah? That means here what I can write? Pi minus P naught, here one more term 4 pi r square, correct now? 4 pi r square. Next Pi minus P naught is equal to T 8 pi r divided by 4 pi r square. So finally what I am going to do, Pi minus P naught is equal to 5 pi will cancel, r will cancel, 4 is 4 2 is 8, 2t by r, 2t by r. So this is nothing but what? Excess of pressure stored in a liquid drop. Okay, Pi minus P naught is equal to 2t divided by r. Can you able to say this? Pi minus P naught is equal to 2t divided by r. So it is a simple derivation. First we are going to consider what? A liquid drop. Then we are going to tell that pressure inside is Pi, outside is P naught. Clear? Next, we know that P is equal to F by A. For that, we will be going to calculate from F is equal to P into A. Okay, F is equal to P into A, where P is nothing but what? Excess of pressure. Substitute excess of pressure as well as A value, which is nothing but what? Surface area for this sphere. So when we substitute all these values, we are going to get this value, F is equal to Pi minus P naught into 4 pi r square. Completely here, due to this force, what is going to happen? It is getting displaced. That means R value is going to increase, which is nothing but R initial will become R plus dr. That means this much quantity will get incremented. So next, this what we are going to calculate. Some work has to be done, otherwise it doesn't holds good. That's why W work done, we know that work done is nothing but what? Force into displacement. By that, in the case of force, we had substituted all the value. Next, if this work has to be done means some energy should be stored in the form of potential energy inside a liquid drop. That potential energy is nothing but what? Potential energy is equal to surface tension into increase in surface area. So increase in surface area, final area minus initial area, we just solved everything. So excess of pressure we got 2T divided by R. Is that clear? Shall I erase the board? Clear? Now in this coming case, excess of pressure in liquid bubble. Clear? Earlier we had discussed for liquid drop. Clear? Now it is for liquid bubble. So once again, so here we are going to consider a liquid bubble whose radius is R. Clear? Pressure outside is P naught, pressure inside is Pi. So shall I write it here? Excess of pressure. So what will be excess of pressure? Pi minus P naught. Clear? Same steps, but only small change. Clear? Same steps, almost everything is same, but only one small change is there whenever we are going to calculate for liquid bubble. Okay? So outside pressure P naught, inside pressure Pi, everything fine. Okay, next. Force on liquid bubble. So now we are going to consider what? Bubble. So force on this liquid bubble. So we know that P is equal to F by a basic definition. Yeah? Or F is equal to what I can write? P into A. Where this P is nothing but what? Excess of pressure. Okay? So F is equal to excess of pressure is nothing but what? Pi minus P naught into area. Surface area for this bubble is nothing but again what? 4 pi r square. Yeah? So due to this force, what is going to happen now? Due to this force, again the radius of this bubble, initially if we choose it as r means, okay, due to this force, r is going to change from r to r plus dr. Clear? So r to r plus dr means here. This value is nothing but what? dr. Clear? Okay. Next, due to this force, this bubble, it is changing means somebody have to do work on that, correct? No? So work done is nothing but what? Work done is nothing but force into displacement. Okay? W is good. F value you can substitute Pi minus P naught. Pi minus P naught into 4 pi r square. What is displacement? Yes, dr. Very good. So displacement is nothing but what? Dr. So if this much amount of work done has to be done means some amount of energy has stored in this liquid bubble. Clear? in the form of what? Potential energy, remember. So if I write our potential energy delta U is equal to what is that? Surface tension into what is that? Increase in surface area. Increase in surface area. So delta U is equal to what is surface tension for liquid bubble? Listen, liquid bubble means it will be having two free surfaces. Here two faces basically. One is inside face, one is outer face. So T value will become what? 2T. Okay, and increase in surface area. Final area is for R plus dr radius. Initial area for R. So what I can write? 4 pi R plus dr whole square minus 4 pi R square. Now it's your step. Delta U is equal to 2T. Okay. Into bracket what I can write? 4 pi as it is. A plus B whole square. A square plus B square plus 2AB minus this value 4 pi R square. So if I multiply 4 pi inside means delta U is equal to 2T 4 pi R square 4 pi dr square plus 4 pi 2 means 8 pi R dr. 4 pi 2 R means 4 2s are 8 pi into R pi R dr as it is dr minus 4 pi R square. So 4 pi R square will get cancelled. As dr value is too small value, dr square will be still lesser value. Clear? So this complete term can be neglected. So what is remaining? Delta U is equal to 2T into bracket 8 pi R dr. 8 pi R dr. Clear? Okay. So this much amount of potential energy is there. That's why it is doing this much amount of work. So just equate both the things. Pi minus P naught into 4 pi R square. 4 pi R square into dr is equal to 2T 8 pi R dr. 8 pi R dr. So dr R will get cancelled. Next pi 4 ones are 4 twos are. Okay, what is remaining? Yes, here see 4 pi R square, this complete step pi will cancel, 4 ones are 4 twos are dr cancel. So pi minus P naught what I can write? 2 into 2 which is nothing but 4T by here on R is remaining 4T by R. So excess of pressure stored in a liquid bubble, it is nothing but what? 4T by R. Clear? So keep studying. Again we are going to make it in our next class. Clear? Thank you.